Good afternoon. Let's start our um, Visual Slope Online Training Session 8. This is the last session we have for this series of training. Today's topic is 2D finite element analysis. This module was added in for Visual Slope version 7 the beginning of this year. The purpose was to enhance our existing functions, such as slope stability analysis. Now we can not only use a slice method, but also we can use finite element analysis for slope stability analysis, which in my opinion is more accurate. The finite element module also help for the others like tunnel, shoring design, even MSE wall. But 2D finite element program can also be used as a standalone tool to help us for many useful analysis. If you want to purchase a finite element program, which can easily cost you $10,000, but it's come very handy within Visual Slope. So today we will focus on how to use 2D finite element as a standalone program. First, let's review the topics we will cover. The first one is basics. Then we will see an example of how do you do a settlement analysis. And after that, we do axisymmetric settlement analysis. And after that, we will give a staged construction example. So let's first go basics. For most projects, actually should be considered as 3D. However, if a project is very long, we are not concerned the longitudinal deformation. In that case, the project can be simplified as a 2D problem. For example, if we have a long highway, we want to make analysis for a section, so we can just cut a slice of the highway and then run analysis. For example, slope, settlement, embankment, settlement. Those can all be concerned as a plane strain problem. The second thing, for example, if we have a very big area, have a circular or a cylinder type of load on the top of that. For example, you have an oil tank, a cylinder storage. For the settlement analysis, we can use so-called axisymmetric analysis, which we will give example 2. So these two are most used in the geotechnical projects. More complicated, if we want to simulate a stage-by-stage construction, and we can also use 2D finite element to simulate that. We will give example for that too. So now let's go just directly to the example. The first one is a very simple one. It's just a settlement analysis. For example, if we have a land on the top, we want to build an embankment, and the top of the embankment is a traffic road. But we want to estimate how much settlement around the base of the embankment. You can do it manually with like a Bushnell's solution, but it's pretty difficult to do. So let's first review what type of material property we will give for this type of analysis. We already discussed the material properties in slope stability analysis and in many cases. So let's look at the soil material. The top is infill, and the bottom we say retain. Just use this as example. So we need add the density of the soil into it, and the other numbers actually is not important for this analysis. For 2D finite element analysis, we need also provide elastic modulus and Poisson's ratio. So these two numbers we need add in besides those typical numbers. Okay. So these are the property numbers we need to add in. Now, the first step for finite element analysis, we go to FEM and choose different analysis. For this case, we use plane string because we think it is very long and we just cut a slice of it. After that, we just generate mesh. There's a different mesh. You can do coarse, you can do fine, very fine, but the most cases, 99% time, you just need basic mesh. So you click on that, the program will automatically generate mesh for you. Okay. So once you finish that, we will run finite element analysis. Say, for example, we just run that, and you find the settlement. And you notice the settlement for this case is so big. It's almost 2 meters. So what's wrong with our analysis? The problem is when we do settlement analysis, we need to know what caused the settlement. In this case, is the embankment caused the settlement. However, if we just run like I did before, it also considers the settlement caused by the weight of the ground. So we have to eliminate those. So the correct way to do is, let's do it again. We generate mesh. After we generate mesh, we need to take the top off. So we go to model, we highlight that, and we deactivate soil. So the embankment will be gone. We also need to take the surcharge out. So deactivate non-soil lines. So in this case, we only have the ground itself. We need to perform analysis. You see, under the weight of the ground itself, it has settlement. It's had quite a big settlement. So after we finish that, we go back and add the embankment back, and also add the surcharge back. And we will rerun finite element analysis. However, before that, we need to reset displacement, in which we eliminate the original settlement caused by the weight of ground itself. So now we run again, and you will see this is a bell-shaped settlement. And if we need to know how large the settlement, you can see this is the settlement. In the middle is the a deep settlement, which is about um, point, 0.4 meters, like 40 centimeters, about foot and a half. To get the detailed data from that, we can use data line. We just go from here, here. Then this table will appear. And this is the horizontal coordinate. This is the vertical coordinate. It should be the same. But this is the settlement number. You can see it go higher, higher. It's about, the highest is about, actually it's not, it's almost a 3.9 to 10 to the minus 1, which is a 39 centimeter. So you can have the number, and if you want to copy the number to spreadsheet, you can copy data, then you can paste it directly to spreadsheet. So this is an example of how to perform settlement analysis for an embankment. I just don't want to mention, in some case, if you know, then that's great. If you don't, that will help you. If the structure, the model itself is perfect, symmetric, the both sides is symmetric, the load is also symmetric. In that case, you can use half of the structure to run analysis. You don't have to draw the whole thing. It will produce the same result. Let me just open the one. I just cut this into half and run it for you. So go back here. This is the same project, but I just used the half of the structure. So you can do the same thing. Go to FEM and choose dance string and generate mesh. After you generate mesh, we still do two steps. First, we remove the embankment. Deactivate and also deactivate those lines. Okay, so this is the one we first calculate the settlement under the weight of the ground. And after that, we add the embankment back. So activate soil lines, activate non-soil lines. So we come back to the original. Now we need to run FEM again and make sure we reset displacement. So once we have that, and do another calculation, you can see this is like half. If you flip this to the other side, actually it will give you another one. But this number should be the same as we calculate previously. Let's do that. And you will see this is the same number as we had with the whole structure, but to save you time. But it's up to you. You want to do both full size, it's okay, but you can certainly do like half size for that. All right. The next one, I will give example of axisymmetric model. So we'll click on that. So this is like a circular, whole circular thing, but we just consider it's, we cut in the middle, and the axial must be at x equals 0. X equals 0. And we now let's run a finite element analysis. But to make sure we choose axisymmetric. And after we finish that, we still generate a mesh. Okay. Similar to the previous one, we take the top off. Take this piece off. This piece is a concrete plate. Take it off, and we activate soil line. We activate non-soil lines. So we have that, and then we run our finite element analysis. So this is the settlement due to the weight of ground itself. Once we finish that, we put the plate back. Activate soil line, and we also activate non-soil lines. So we have those. Once we finish, we run finite element again. However, we need reset the displacement. So you will see this is the settlement caused by this. Is, say it's a plate or a slab with a surcharge on the center. You will see what type of deformation will have. So you can see this is the settlement part. Same way, you can correct the data from this line. You will see this is the settlement. So this is axisymmetric condition. Okay. So the last one we will do is I give another example just to see how do we do staged construction. And we open that. Okay. So this is example. It's a real project. We have a ground. We want to add sheet piles into it on both sides. And we start to excavate. And after we excavate to that level, we add a bracing to the top. Then we continue to excavate to the second level. We add another bracing. And we continue to excavate to this level. And we will add sheet piles into it and excavate to here. And we add this bracing into it. Continue on, and we add more bracing, and we add another sheet piles into it. Eventually, we will excavate to here. So it's like the shape is something like this. So we want to calculate the ground deformation for each step of excavation. So what we need to do is we choose plane string, and then we do mesh. It asks you, do you want to include the piles? So yes. So the mesh has been generated. The same way, we will always eliminate the original settlement caused by the ground, the weight of the ground itself. So the first we do is we take all the sheetings out. The sheetings out. So we do not have sheetings. Then we run a finite element just like we did before. So we finished that. Then we need to put two sheetings in. So what we do is go to model and add the sheetings, or just add both things to it. So add sheetings into it. But those things should not be added in. So I will take those off. Deactivate those. And I will take this line out, so you can do this. And deactivate soil lines. After that, now we need to run a finite element analysis. Make sure this is on. But you can do that. So this is what happens after you run. You can continue to do it step by step. However, if there's so many steps, if you made a mistake, then you have to do it over again. So to save your time, you can say save set stage. It will ask you, do you want to set stage? You say yes. So this stage has been set. So no matter what you do, if you click on that, it will go. Let's just do that. Let's save it. Save it. So once you open that, it's original. It's something like that. So you already have the stage set up, but you can do one by one. But assume I already finished all the stage. Each stage I saved it, so you don't have to redo again. You can just go directly. Let me open the one I already did. So you have originally is like that, and set mesh and include piles. And the one you did, you can, this is the original stage, there's nothing. Then you can go the next one, which does not include any structures. So you can run analysis. Once you finish, you can run another one, which has only two of these, and excavate to that. And we set this on, and we run analysis. So you can see this, and you can continue, move on to the next stage. You already saved it. And this time we won't have this off because we want to accumulate the deformation. So you have this. The same way you can go on for stage 5, and you can calculate. But this will be make very easy for a staged construction. You can save every stage and run analysis. So it is pretty easy for you to use visual slope to run a finite element analysis. Hope that will be helpful for you and for your project. This concludes our presentation today. And thank you so much for your participation. And if you have any questions, you can always email us at help@visualslope.com. Thanks again. Have a good weekend.